Okay, so who can tell me how you would take this function and get to the standard graphing window? Right now, if I look at my graph, it's not a very good window. There's a terrible window around my function, and I can't really see anything about the function. Can somebody tell me how you get back to just the standard window, the 10 by 10 window? You can just unmute and say it.
You hit zoom, then you press 6.
Perfect. So zoom 6 is the standard window, and it takes me here. Now, last time we kind of looked at this function a little more, we can't really see a lot of detail going on like around in here, okay? But we looked at these different viewing windows to see which one gave us a better window. And we decided that this second one gave us a little bit of a better window because we could see more detail about the function. So how do I change my window so that it is these values now? How did we do that on the calculator? What button do I push?
The window button?
Yes, Noah, thank you. The window button. Okay, so if you want a better window, it makes sense to go to the window. So there's our X min, X max, and then Y min, Y max. Okay, you also have an X scale. So this is like what you want your little tick marks to go up by if you ever wanted to change that. So I'm going to change the X min to -0.2 and the max to not negative, but 0.6. And then the Y min, I'm going to change to -0.06, the Y max 0.02. And so here's my graph. Now, once we got that window, we can now see that there are relative max and mins on this function. So what did we say a relative? Can somebody tell me what a relative versus an absolute max is? Come on, people. You can do it.
The relative max?
Perfect. Go ahead, Noah.
Okay, the relative max is when it goes from increasing to decreasing.
Perfect. Does it have to be the highest point on the graph?
No.
No. Okay, so that's kind of what differentiates. An absolute max is the highest point on the graph. So we have a place where the graph does go from increasing to decreasing, so that creates a max here. But this side of the function over here on the right, we can see is going to continue to go up forever. All right, so I want to find this. I want to approximate. So guys, if I ask you to approximate the relative max, then what I'm asking you to do is find the point where the maximum occurs over here. Do you remember how to do that, or have you done that before using this calculator? Okay, so if not, this is how you're going to go about doing that. So I'm going to look right here. So if you look at the trace button, over it, it has this little calc. Okay, so you can calculate a lot of different things about the function with that feature. So I'm going to hit second trace, and then it brings up a list of a lot of different things the calculator can calculate. So I'm going to calculate a maximum value. So I'm going to calculate the fourth option. Now, the first thing it's going to ask me for is a left bound point. So if I'm estimating that the max is somewhere around like right here, I need to take this cursor to the left of that point. And it really doesn't matter how far left I go, just somewhere kind of relatively close to the left of the max. So I'm going to hit enter. Then it asks me for a right bound point. So I'm going to take it to the right. Somewhere, doesn't really matter how far over to the right. I'm going to hit enter, and then I have to hit enter one more time because it's going to say, do you want me to guess what that is? And yes, I do. So the max is, now guys, if you see this notation here, a lot of times these calculators come up with this scientific notation, this e to the -6 or e to the -12. What does that basically mean? What is that telling you?
There's a lot of decimals after.
Yeah, it's kind of like, it's like scientific notation. So if we just take this first one, what this means, so if I take -1.835, and then that e is kind of like times 10 to the -6. Y'all have seen scientific notation before, right? So what that means is I'm going to take this decimal and move it to the left because it's negative 6 places. So 1, 2, 3, 4, 5, 6. And then I'm going to fill that in with zeros. Okay, my negative is out here. So guys, what does this basically round to? If I wanted you to round to the nearest tenth, what would that round to? 0.00000. Anybody? 0, yay, good job me. Okay, guys, 0. Do we understand why that's 0? Yes? Okay, so the relative max is going to be 0, 0, because this y coordinate I would do the exact same thing with, okay? Now, I want to find the relative min as well, so I'm going to calculate second calc again, and then I'm going to go down to min this time. Okay, it's same process. It's going to ask me for a left bound point, so I'm going to go somewhere, doesn't matter exactly where, but to the left of the min. I'm going to guess the min is somewhere around here. Then I'm going to go to the right. And then I'm going to tell it, yes, I want it to guess. So the min is 0.33333, and I'm just going to have you round these to the nearest, I think I said 10th on the quiz. So the relative min, let's see, where is it at? Right here. So relative min is going to be at 0.3, and I'm going to round this to negative point. I'm just going to round this to the nearest hundredth because of my decimal here. So I'm going to round it to negative 0.04. Okay. So that would be my relative min. There are no relative or absolute, maxes or mins, okay, because my graph is going to shoot off in each direction, kind of like we drew right here. So there's no absolute max, no absolute min for this function, okay? Any questions at all? Okay. All right, so guys, now we are here to this example, okay? So we want to do the same kind of thing, okay? So I want to use a little bit of a different function, but I want you guys to try to fit your own viewing window around the function first, okay? So we're going to graph that function and try to fit a nice window around it so that we can see what the details are, or the relative maxes and mins. Okay, we also want to be able to see the intercepts. So does the calculator have does the graph have intercepts? And if so, we're going to find them using the calculator, and I'll show you how to do that. And then are these points exact or approximate? And then we're going to actually go find the intercepts without a calculator, okay? So I really want you to just kind of try this quickly, okay? So I'm going to give you just a second. Does everybody have a calculator here? Because if you don't have a calculator right by you, then I know Ava, you don't, but other than Ava, does everybody have a calculator?
I don't.
I don't either.
Okay, so let's just go through it together. Do you have access to one, or do you just not have one with you right now?
I guess I could steal my brother's.
Don't worry about it right now. We'll just do it together. But just know that eventually you'll probably, I say that nicely, you're going to want to get one eventually. Okay, so here, let's type this in. So we've got x cubed minus 2x squared minus 2x. I'm going to start out in my standard window. So I'm going to hit zoom 6. Okay, so here's my window. It's not a terrible window automatically, but what I'm looking at is I really don't need to see all of this extra space out here to the left or to the right. And I don't really need to see up here so high or down here so low. What could I possibly do, or what might I change my window to make it a little bit of a better window so that it's more zoomed in?
Like decrease the x-axis.
Yeah, so I can decrease in my window. I can decrease the x min and x max. I want to show you another kind of neat feature to your calculator. I don't know if you've ever done this before, but have you ever seen, if you go to Zoom, have you ever seen the Zoom box? Has anybody ever used Zoom box? I like to use it because I just like to say the word Zoom box. But Also, it's very handy, okay? So zoom box is really nice if you have a function kind of like we have. So I'm going to go to that option, and then I'm going to take my cursor up here. And so if you can remember this much, then you can use zoom box. So basically the cursor, when you initially move it, is the left upper hand corner of the box. Okay, so I'm going to hit enter right there. And then I'm going to bring down the left side of the box. And then I'm not going to hit enter, but what I'm going to do is pull the box out now to create a beautiful window around my graph. Yay. Okay, so there's what I want to zoom in on. And so now when I hit enter, it's going to take me directly to that boxed in portion of the graph. Okay. So it's a nice little nifty feature that you can use. Okay, so I just wanted to show you that, and I'm just going to write here, zoom box. Okay, is what will help you with that. Okay, so does it appear that this has intercepts, y or x intercepts? Yes, it does. Okay, so let's go through. I'm going to show you how to find one. It's a very similar process to how we found the maxes and mins. And then I'm just going to give you the rest to save some time. Okay. So for the intercepts, let's go to the calculate button again. So second trace or second calc. This time I want to calculate a 0. Okay. So I want to find a 0 or an intercept. Now let's find this first intercept over here where it crosses the x-axis. So I'm going to go to the left of that intercept. So I would guess that the intercept is somewhere around there. If I go to the left of it, it's going to be somewhere below the x-axis. Okay, so I'm going to hit enter right there. The right bound is going to be somewhere above, maybe right there. And then I'm going to hit guess one more time. Okay, so I'm going to round that to negative 0.7, comma 0. Does anybody have questions on how we did that on the calculator?
Wait, yeah, what was the first button you hit?
So the same thing that we hit whenever we want to find a max or a min. So I'm going to hit second calc, and then I want to find a 0. So if you're finding an x-intercept, the word that the calculator uses is a 0. Okay. And so then once you hit enter, you want to find that, you'll go to the left and the right of the intercept. So guys, if I'm finding this next one, it looks like it's at 0, 0, but we'll make sure a left bound point is going to be somewhere above. Okay, so I'm going to say, sure, that looks good. A right bound point is going to be somewhere below. And then I'm going to have it guess. And then 0, 0 is my other y-intercept. Okay, any questions on how to find that using the calculator? Okay, if not, I'm going to go ahead and give you this last one. So there's one more, and we're going to round that to if we went and found it 2.70. Okay, so are these intercepts exact values or are they approximate values?
Approximate?
Yes. Okay, so these are approximate because I had to round these. Okay, so we had to round the values, and so that's what makes them approximate. So if I ask you on the quiz to find approximate values, this is what you would do. You'd use your calculator, you would round to whatever place I tell you to round to. But if you want to find the intercepts without using a calculator, those are going to be exact values. Okay, so for exact values, how would I go about using that equation to find exact values for x-intercepts? How would I do that?
Wouldn't you factor it out and then set equal to 0?
Perfect. Yes, that's exactly what I want to do. So if you notice all of these values right here, the y coordinate is 0. So exactly what Noah said, I'm going to let 0 get plugged in, or I'm going to plug 0 in for y. And then I'm going to try to factor this. The first thing I'm going to do is factor out a GCF. So the GCF is x. That leaves me with x squared minus 2x minus 2. Now, will this give me something that factors? No,
No.
unfortunately, it will not. So how would I have to use this quadratic to, or how would I solve the quadratic?
Uh,
Quadratic formula.
Perfect, thank you. Quadratic formula. So I'm going to go ahead and say from this factor, I can see that 0, 0 is an intercept. Okay, 0, 0 is an intercept there because if I set x equal to 0, it's already solved. We already know that the y value has to be 0, so this is my intercept for this factor, okay? For these factors over here that we're going to end up finding, I'm going to use the quadratic formula. So I'm going to say my x-intercepts are going to equal negative b plus or minus square root b squared minus 4ac all over 2a. Does anybody want to volunteer to sing the quadratic song? Yeah? No?
X equals negative b.
B plus or minus square root. Keep going.
B squared minus 4ac.
All over 2a.
There's a song?
Effort. Good job. Okay, so that's our quadratic formula song. That's what we're going to use here. So I'm going to go ahead and plug my values in. So the opposite of b, or negative b, is going to be 2 plus or minus. Negative 2 squared is 4. And then minus 4 times 1 times negative 2 all over 2 times 1. Okay, so this is going to end up simplifying to give me x equals 2 plus or minus. This is going to become 4 plus 8. Okay, so 4 plus 8 is going to give me 12 over 2. And then I can simplify this radical a little bit. How does root 12 simplify?
2 root 3.
Perfect. All right, now what we're left with is the exact answer, but I can simplify this a little bit more. This has what I like to call the love triangle. Okay, so do you see how all these numbers outside the radical have a common factor? 2 goes into all of them. So I call this the love triangle. We don't want to leave that. Love triangles are never good. We want to get rid of it. So I'm going to divide everything by the common factor 2. Okay, so x equals 1 plus or minus. This is going to become 1 as well. I'm just going to leave it root 3 over 1. So really I can leave my answers like this. Okay, so if I ask you for exact intercepts, this is what you would say. 0, 0 is an exact intercept, and 1 plus or minus root 3, 0 is an exact intercept. Okay, and so that's what I'm looking for, is that radical value, not a decimal approximation. Okay. All right, guys, everybody okay with that? Feeling good? Okay, so let's quickly go through. I have at least 2 to 3 more examples that I want to quickly do. And we're just going to find the x-intercept and the y-intercept this time by hand. So we're going to find the exact values. Now, we just found x-intercepts, and we did that by letting y equal 0, or by plugging in 0 for y. So that's exactly what we're going to do here. Our equation is a little bit funky. We could go ahead and try to solve for y, but that's just extra work. You don't have to do that, okay? So I'm going to go ahead and plug in 0 for y. So x squared times 0 minus x to the third plus 3. Okay, this term is just going to be 0. So x squared times 0 is just 0. So I'm left with this. Now, how would I solve for this? Or how would I solve for x here? Anybody?
You would subtract 3 and then take the cube root.
Perfect. So I'm going to subtract 3. Before I take the cube root, I'm actually going to go ahead and divide by this negative to get rid of that negative out front. So that's going to give me x cubed equals 3. And then exactly what Noah said, yes, I'm going to take the cube root of both sides. So if I want exact values, I want you to leave your answer exactly like this. Okay, so the cube root of 3 comma 0 is what I'm looking for there. Okay.
Wait, is that a y-intercept or an x-intercept?
That's an x-intercept. Okay, so for x, we plug in 0 for y. For y, we plug in 0 for x. Okay, so this is my x-intercept. For the y-intercept, I'm just going to switch the variable that I'm actually plugging in 0 for. Okay, so this one is a little bit faster to solve. I'm going to plug in 0 for all the x's here. So I have 0 squared times y minus 0 cubed plus 3. How does all of this simplify? What happens here and right here?
0.
Yeah, this is just 0 plus 3. Okay, so 0 plus 3 equals 0. That means 3 should equal 0. Is this a true statement? 0 equals 3? No.
No.
That indicates is that there is not a y-intercept. Okay, so if you end up with a statement that's not true, there's no y-intercept for that graph. Okay. All right. Couple more examples, guys, and then we are done. Actually, one more that I want to make sure that we go over. Okay. So let's look at specifically one like number 5. So guys, you may want to star this because this is something that you need to keep in mind whenever you're solving problems like this on the quiz. Okay, and for your homework. So let's go ahead and find the x-intercept of this first. Now, when we find an x-intercept, what do we plug in 0 for?
Why?
Y, perfect. So f of x is kind of like y. So 0 equals 7x plus 8 over the square root, blah, 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 blah. And I'm not even going to write this out because what's always going to happen, so guys, see this because this is something that's going to save you some time, okay? So anytime you have a fraction and you set that fraction equal to 0, what's going to happen every single time if you go try to solve this, I would multiply the bottom part over, or you can think about putting 0 over 1 and cross multiplying. Every single time 0 is going to get multiplied by whatever's in the bottom. And 0 multiplied by whatever's in the bottom every time is just going to give you 0 equals, and then 1 times the top gives you back what's in the top, okay? So shortcut is, when you set a fraction, so for 2, 3, 4, when you set that fraction equal to 0 every single time, all it really is doing is just setting the top equal to 0, okay? So let's go solve this, okay? So let's look at solving this. I would subtract 8, divide by 7, okay? So it looks like x is going to equal negative 8 over 7, okay? Does that make sense? It looks as if it's going to equal negative 8 over 7. Now, I'm going to pause right there and go to the y-intercept, okay, real quick. So the y-intercept, and then we're going to go back and look at that real quick. So for y-intercept, I'm going to let x be 0, so I have y equals 0 plus 8 here over the square root of 0 minus 6, which is negative 6, okay? So that's going to give me 8 over root negative 6. What kind of number is this going to give me from the denominator, this root negative 6?
Irrational.
Close.
Or sorry, not irrational. What's it called?
Another hour.
Imaginary. Yeah.
Yes, imaginary. So guys, it doesn't make sense for you to have an imaginary intercept. Like, you can't have an imaginary intercept. So this just indicates that there's no y-intercept here for this function either. Now let's go back to this. If you have something that has a denominator or a radical or anything like that, if it's not just a nice kind of pretty polynomial, what we need to think about is if I plug this in, if I plug in negative 8/7 for x, okay, what can we not have on the bottom of a fraction? 0, right? What can we not have in a square root? A negative, okay? We can't have a negative. So what we need to do is make sure that we think about what is this value that we got from the top going to give me if I plug it into this denominator. So what I'm going to do really quickly is type in negative 8 over 7 squared. I'm going to type it into this little quadratic underneath here. minus -8/7 minus 6. Okay, so I'm going to get this value here whenever I type that in. Okay, does everybody see how I typed -8/7 in and then I got a negative value as a result? That means that this value that I thought was an x-intercept actually gives me an imaginary solution underneath this radical. And that cannot happen for an x-intercept. So what this really means is that there is no x-intercept for that either, okay? So you have to make sure that what you get for your x-intercept doesn't actually give you 0 or an imaginary number, okay? And if it does, it's not going to actually be an intercept, okay? Now, oh crap, I just went over 2 minutes. Okay, so I'm going to let you go really quickly. Homework is this, okay, for section 1.5. And the intercepts worksheet, just do the odds. Okay, check your answers tomorrow at 1 o'clock. We have office hours, so if you have any questions at all about that, please come. You can also do the optional quiz review if you want to. Okay, any questions? Okay, guys, I'll let you go. Sorry I'm over. See you.
Thank you.
Thank you.
Thank you.